Making a tiny lab power supply based on USB-C.
Hi folks, I was intrigued by the specifications of the USB-C power supplies. A USB-C power supply for a laptop, for example, can provide like 65 watts of power at up to 20 volts. That's pretty impressive. So decided why can I not build a small power supply that is fed by the USB-C? And it's become possible to tap these USB-C power supplies if you get this tiny little USB-C decoy boards. On these tiny boards, you can select any of the available voltages from 5 volts to 20 volts. I also had an adjustable power supply module from a while back with built-in digital meters for voltage and current, and it had constant current and constant voltage feature, which is pretty useful. This module went from 1 volts to 25 volts and could supply up to 2 amps of current. So I thought it would be a good fit to see how I can hook it up to a USB-C decoy supply. Volts output. The final design is pretty simple. It's just three modules hooked up to each other. The USB-C module produces 20 volts, 3 amps. This is then upconverted to 27 volts, and this 27 volt is then fed to the variable power supply module. This would produce the variable 1 volts to 25 volts at up to 2 amperes constant current. Plus, of course, some hardware such as a switch for power, three-way terminals, and nuts and bolts. So, not much to make a pretty neat supply. To start with, I designed a 3 by 3 by 2-inch box in FreeCAD. This is something new for me working with FreeCAD. And a big shout out to Mango Jelly Solutions and others on YouTube for producing great tutorials. So then once the design was done, I printed the box on an Ender 2 Pro with standard black PLA. So the top that I'm showing in the design here, it holds pretty much everything: the switch, the terminals, the output terminals, the potentiometer, and the big variable power supply board. There's a scrap piece of aluminum as a jury-rigged heatsink for that power supply IC and this thing. The heatsink was glued with thermal epoxy, and you can see some white sponge pads, which just basically was helping me kind of keep the thing clamped while the glue cured. This is another view of the so-called heatsink popping out its head. I don't know how useful this will be, but it wouldn't hurt. The base holds the two remaining components, the USB-C decoy that converts the USB-C for accessible supply, and the up converter, the voltage up converter. Unfortunately, I did not take pictures or videos of the final connecting all the wires together in this tight space, but somehow I got it all together. And the front view beautifully hides the mess behind. So it's a very nice photograph because it hides the reality. Once I had the front panel done, I then moved to the base, soldered the wires to the USB-C decoy, the output wires, attached the up converter, and adjusted to 27 volts. I then connected the positive from the up converter through the power switch to the variable power supply module. And again, remember, I soldered it to the power supply module and the negative or ground from the up converter to the negative input of the module. The outputs of the module, the variable power supply module, were directly connected to the three-way banana plugs as shown in this wiring diagram. And finally, I managed to get it all squeezed into this tiny box, which I think increased my struggle a bit. And by the way, you might have noticed the little transparent light tube rectangle on the right. This shows the status of the LEDs. It essentially carries the LEDs, the light from the LEDs on the board into the surface so I can see what's happening. So when it is in constant current mode, for example, the LEDs turn to yellow, orange, or red. So I can see when I'm CC mode. Uh, and here, I guess this is a headshot of the final power supply with the USB connector plugged in, and then switched it on. Relief, it works. I did a final test by connecting the outputs to a 12-volt incandescent bulb, to check, what is the current, because I couldn't monitor a current without a load. So the bulb served as a good load. And you can see as I adjust the current and the voltage, it pops into constant current mode with the LED changing to yellow or orange. When in constant current. Really happy with this little PSU. It's